So let's talk about the Bermuda Triangle. I think it's fair to say it's probably the single most famous and maybe most terrifying stretch of ocean on the planet.
Oh, absolutely. It's more than just a location on a map, right? It's a global legend.
Exactly. It sort of defines that feeling of inexplicable, instantaneous fear.
Hmm.
You know, the dread that you could be navigating perfectly one minute and the next, you just cease to exist.
And that legend, it's really rooted in genuine loss.
Yeah.
This is a high-stakes puzzle because the sheer volume of recorded disappearances is just, well, it's staggering.
Right.
Our source material confirms these strange disappearances go all the way back to the early 1800s. We're talking over 1,000 ships.
1,000.
And more than 70 planes have logged these strange, unverified vanishings within that region, between Florida, Bermuda, and Puerto Rico.
So our mission for this deep dive is really to get past the folklore and unpack the specific and often terrifying theories that the research gives us to try and explain all this loss.
And the key, as you said, is the speed and the silence.
Yes, the speed and the silence.
Exactly. We're not talking about, slow sinkings where a captain has time to send an SOS.
No.
The records show these catastrophes unfolding sometimes within seconds.
Okay.
And there are 0 distress signals ever transmitted. The vanishing it's instantaneous and it's total.
When you look at those numbers, 1,000 ships, 70 planes, you have to think that, well, conventional weather and human error, they just can't account for the pattern.
Weekend.
We have to be looking at geological, maybe meteorological mechanisms that are unique to this zone.
That's the core of it.
Yeah.
What is the convergence of factors that allows this one stretch of ocean to become so uniquely lethal?
Okay, let's unpack this, and let's start exactly where the losses began, the maritime mysteries.
Mm-hmm.
What's the most compelling natural explanation for a huge steel ship just vanishing so quickly?
Okay, so if we start with the ships, the theories immediately go towards these really dramatic, sudden changes in the environment.
Things the crew would have no time to react to.
No time at all. And the leading natural explanation that really addresses that speed is what's called the methane eruption hypothesis.
The methane eruption hypothesis. Okay, that sounds almost geological in its scope. Explain what that is.
Well, it is. We're talking about massive trapped deposits of methane hydrates.
Right.
These are basically frozen cages of water molecules holding huge amounts of methane gas. And they're stored under intense pressure on the seabed floor.
And this region has them.
This region is known to have some of the largest deposits on the entire planet.
So what sets it off? What's the trigger?
It could be seismic activity, a sudden change in temperature, any kind of geological shift that destabilizes these hydrates.
And then what happens?
Well, that trapped gas can rapidly turn from a frozen solid into an enormous bubble that just rushes to the surface.
Oh, wow.
And when that happens, the gas bubble instantaneously reduces the water's density right above the eruption site.
I see. So a ship, it doesn't matter how big it is, it relies completely on the density of the water to float.
For buoyancy, exactly.
So if the water suddenly becomes this gas-infused foam instead of a dense liquid?
The ship loses all of its physical support.
Mm-hmm.
It doesn't sink slowly, taking on water. It loses its lift instantly.
Wow.
The source material describes it as the ship dropping immediately, as if it has fallen into a hole in the ocean.
That's a hole in the ocean.
It's a rapid, silent mechanical failure caused entirely by geology, and it leaves no time for a radio call.
That is a terrifyingly coherent explanation for why a ship would sink so fast, but if that's true, why aren't we seeing this in other places? Like the Norwegian Shelf or the Arctic, they have big hydrate deposits too, right?
That is the challenging question. And that brings us to the second element of the puzzle for ships, navigation failure.
It's okay.
Because even if your ship is still floating, if you don't know where you are set up for disaster. And this leads us to the theory of magnetic disturbance.
And we're talking about something more than just a regular compass variation here.
Oh, much more. The research notes these highly localized magnetic disturbances. Some people even call them magnetic vortices.
Vortices!
And they cause just unprecedented chaos for navigation equipment. Compasses become erratically distorted, completely unreliable in the region.
So you have a geological risk that can literally swallow you whole.
Mm-hmm.
And that's compounded by a magnetic risk that makes sure you're already lost and sailing blind if the weather turns bad.
Exactly. You combine those two specific, very unusual factors, and the Bermuda Triangle becomes a kind of perfect storm generator, even before we talk about what's happening up in the air.
Okay, so if magnetic anomalies and methane bubbles explain the ships, we need to talk about the aerial mysteries, because this is where it gets, for me, even more complex.
Hmm.
What explains a large plane commercial, military disappearing in midair, sometimes at a stable cruising altitude, without a single signal?
Well, this takes that same challenge of magnetic interference and it just throws it tens of thousands of feet higher into the atmosphere.
Right.
And then it adds this incredibly volatile meteorological layer on top.
So let's start with that. Navigation failure in the air. We're not talking about a simple compass. Modern aircraft have incredibly sophisticated avionics.
They do.
Can the magnetic field corruption really affect a plane that's mid-flight?
According to the scientific reports cited in our sources, absolutely. They detail a strong magnetic disturbance that is powerful enough to corrupt the aircraft's most sophisticated navigation devices.
Even things like inertial reference systems or GPS backups.
Even those. If those systems are compromised, the plane is flying blind and it's flying off course at the same time.
And flying blind means they could fly directly into extreme weather they can't see coming.
Which leads us straight to the most dramatic and unique theory for aerial failure. The atmospheric air trap.
An air trap?
Yes. And this is tied to some very unusual meteorological phenomena that have been reported in the area.
Okay, this is the hexagon-shaped clouds, right?
Right.
What makes a hexagonal cloud so lethal?
Well, these reports describe these bizarrely shaped hexagonal clouds. And unlike normal storm clouds, these formations are believed to channel and organize intense, high-velocity airflows,
Creating what?
creating incredibly powerful and deadly downdrafts. Essentially, atmospheric microbursts on a massive scale.
And our sources actually call these killer winds, and they give a specific speed for them.
They do. These killer winds are reported to travel at speeds up to 270 kilometers per hour.
270.
To put that in perspective for you, that is faster than many hurricane-force winds.
So imagine a plane hitting that force suddenly from above or below, mid-flight.
A 270-kilometer downdraft would.
Yeah.
It would tear the wings off a plane, or it would drive it straight into the ocean,
Before the pilot could even register what was happening.
let alone activate the radio. It perfectly explains the instantaneous nature of the catastrophe.
And there's actual, instrumental evidence of this happening.
There is. The sources note this chilling radar phenomenon. You have radar recordings that are tracking the plane, and then suddenly, without any decay or deviation, the blip just vanishes.
Gone.
The analogy they use is haunting. It's as if someone wiped it off the screen. 1 second you have confirmation, the next, total void.
Which suggests what? Instant physical fragmentation? Or some kind of severe electronic interference?
It could be either.
That's total.
So we have these highly specific, scientifically plausible mechanisms for instantaneous destruction.
Right.
Methane, reducing water density for ships, and these 270-kilometer or killer winds from weird cloud structures for planes. It explains the speed.
Correct. But this raises an even more important question. One that unites all the disappearances, ship or plane, and moves us into the realm of the truly mysterious.
And what's that?
Why is the greatest puzzle not the initial catastrophe, but the total absence of debris afterward?
That's it. That is the defining characteristic of the Bermuda Triangle compared to any other dangerous place in the ocean. If a plane with thousands of gallons of fuel crashes or a massive steel ship sinks, there should be evidence. And we have to acknowledge the physical reasons that could account for some of the missing wreckage.
Sure.
First, just the geography of the area. The sea floor in this region is incredibly deep.
How deep are we talking?
In some of the trenches, it rivals the deepest parts of the Atlantic. So finding a small piece of fuselage, thousands of meters down, scattered over a vast, dark plain, it's nearly impossible.
And even the stuff that does float gets pulled away almost immediately.
Absolutely. The region is known for its strong, complex currents. Parts of the Gulf Stream run right through it.
Right.
These currents are constantly twisting any wreckage, scattering it, and carrying it hundreds of kilometers away from the point of disappearance within hours.
So search efforts are almost always starting in the wrong place.
They're starting at empty coordinates, yeah.
But the truly inexplicable cases, they seem to defy even those explanations of depth and current.
They do.
The cases that suggest a total vanishing act, where the search teams arrive at the last known coordinates and find the site, just completely empty.
And that's the key piece of evidence that makes researchers scratch their heads. The sources highlight these mystery cases, where search teams found the area totally void of any trace.
And there's one specific detail that's even more damning to the conventional crash theory.
Yes, the fact that there wasn't even a trace of a fuel slick. Not a single blemish of oil on the water to indicate that an object carrying thousands of gallons of fuel had just hit.
That lack of a fuel slick, it suggests the object didn't just sink and displace water and fluids, it just ceased to be there.
The feeling you get from those who study these accounts is that the body vanished. It didn't just sink.
It's a profound difference.
A huge difference. When you remove the fundamental evidence of a sinking, the wreckage, and the fuel slick, you're left with only one conclusion: total disappearance. And this is where all those strange environmental factors come back into play.
Right. So did the magnetic disturbance cause the plane to instantaneously disintegrate? Did the methane release not just sink the ship, but somehow dissolve its structure?
These are the questions with no answers.
So, I mean, what does this all mean? We have mechanical and geological theories for the speed. We have environmental theories for the total failure. And then we have this bizarre evidence of non-existence.
And that absence of evidence, combined with the extreme nature of the explanations, the killer winds, the methane,
Ugh.
that's what inevitably leads to fringe speculation.
Sure.
Our sources do acknowledge these non-scientific theories. Things like the area being a powerful gate or a portal.
Or a zone of some gravitational anomaly.
Right. And these ideas are easy to dismiss as non-scientific.
Of course.
But they really underscore the frustration that the physical evidence, or lack of it, presents to scientists.
So if we stick strictly to the conclusions from the solid research, what's the primary takeaway?
The primary takeaway is that no single confirmed explanation exists. Not one theory, not methane, not the wind, not magnetic fields, can account for the sheer variety and scale of losses we've seen over the last 2 centuries.
So after all this time, all this investigation, sophisticated technology, dozens of plausible theories, what is the single agreed upon certainty about the Bermuda Triangle?
Only one thing is confirmed by the sources.
Ah.
The danger is entirely real.
Even if the precise mechanism is still elusive.
Even then, anything entering that area is simply not guaranteed to come out.
It's just fascinating how a global legend can be distilled down to such specific, terrifying mechanical details. The idea of a gas bubble just instantly reducing water density beneath a ship. The reality of those 270-kilometer-hour killer winds from these bizarre cloud formations, and that ultimate chilling observation that sometimes there wasn't even a fuel slick left behind.
It's true.
For you listening, if you're seeking clarity on this mystery, understanding that convergence of specific lethal environmental factors, that's the key to moving beyond just sensationalism.
And it also highlights the limitations of science in defining the past. We can propose these very robust mechanisms for destruction, but if the ocean is too deep or the current's too strong...
For the destruction too complete.
Exactly. Even the most sophisticated investigation can be defeated by a total lack of observable evidence.
So here's something to think about. If the methane and the air traps are the known tools of destruction, but the defining mystery remains the total absence of debris, this instantaneous erasure of all evidence, does that focus the question less on how they were destroyed and more on what mechanism could facilitate a perfect, evidence-free vanishing in that specific zone? That's something to mull over as you consider where geology and legend meet.